Hey, we're looking at Light Notes Part 2, so we're going to skip to the second page. And it talks about light, shadows, pinhole images. We have some terms we didn't mention in the Part A labs, but we'll also get to the Part A. So transparency says it's a measurement of how well light can pass through a material. So something that's transparent will easily let light pass through, and here are some examples. And something's translucent will let some light through, but not all. And some of the light may be absorbed, reflected, or scattered. And so if you think of frosted glass you might have on a bathroom window, that'd be a good example of something translucent. Opaque is a material essentially blocks light. Light cannot pass through, and again, there are the examples. And these diagrams are trying to illustrate the difference between transparent, translucent, and opaque. Now, when light hits an opaque object, the light is absorbed. Some light might be reflected, but we're not interested in that in this section. We're interested in the fact that we can get a shadow. The light's blocked, so on the far side of the object, no light is going to reach it. In the lab, you did light, penumbra, and umbra in activity A2. Light, where you got light from both light sources. Penumbra, you got light from one source, but not the other. And umbra, received no light from any source, and you end up with a dark shadow. That will apply to eclipses. So here we have a diagram of a solar eclipse and a diagram of a lunar eclipse. You're responsible for the description here and the diagram. In a solar eclipse, we're camped out here on the Earth, and we can't see the sun because we're getting the moon's shadow. Now, when there's a solar eclipse like we had, I believe, in August of 2017, with that eclipse, it did go quite dim at the time of it because we were close to a total solar eclipse in this region. And so that meant the shadow did pass over us. In other areas that weren't part of the path, they would have been unaffected. In a lunar eclipse, now instead of the moon being in the middle, the Earth is in the middle. The Earth is casting the shadow. And that shadow will envelop the moon, and the moon will move through it, and it will often have very interesting colors. Orange colors as it leads up to it and as it comes out of a total lunar eclipse. Now, I should backtrack. When we get a solar eclipse, that happens in the new moon phase. And when we get a lunar eclipse, that happens in the full moon phase, where we can easily see the moon. And one of the other interesting things is, just by chance, the distance from the moon to the Earth and the sun to the Earth when we have a solar eclipse means the moon, even though it's smaller, can pretty well totally block out the sun at given points on the Earth's surface during a solar eclipse. So at that point, they look like they're the same size, even though they're not. So you definitely have to know about eclipses. The other part of A was all about pinhole images. More evidence that light passes through things like air in a straight line. In the pinhole, the light crisscrosses, and anytime light crisscrosses, bottom becomes top, top becomes bottom, and yes, you have to fill in all these terms. And the image is upside down, and often we say inverted. Now, for what we did, it would just be the flame that's coming through like this. We would only get the flames image on our screen. That's why it says that here. And it used to be 20 some odd years ago, we actually did labs where we did pinhole photography, but I think that's moved over to another class where they will go and take pictures with pinhole cameras. That's it for part 2 of Light Notes. Watch for part 3 where we will look for reflection and mirrors.